Hi everyone. I guess we are live now. And so the idea of today's stream is to learn the Odin programming language. And what I will do is I'll go through this documentation that we have on the original website of the Odin programming language. And what I'll do it, I will paste it in my description as well. And I'll just quickly give it in the chat. Right. So this is what we are going through today, and we'll try to cover this entire page. Let's see how much time it takes. And the idea is to get started with learning this programming language so I can make some content out of it. I have some cool ideas with me that I can implement, so I can use different language. So don't think that this is just limited to Odin programming language. I'll be using Go. I'll be learning Zig. So Go is something I'm familiar with. I'm familiar with Java, a little bit of C, C++, and Python. Yeah. So I just wanted to learn a low level programming language, and I heard about Odin. Odin is an alternative to C as much as I know, and it's supposed to give you the modern programming language features. And yeah, so let's see how it goes in this stream or the video if you are watching it offline later on. And if we get someone to chat with, that would be pretty cool. So let's start with the introduction part. This article is an introduction to Odin programming language. You are assumed to have basic knowledge of programming concepts. So we do have basic knowledge. You will see how familiar things are done in Odin while also being introduced to new concepts. Okay, so if you haven't already installed Odin, you can go here. So if you want to follow along, go and install Odin for your operating system. For my operating system, what I had to do was simply do brew. Since I'm on macOS, I did brew install Odin, and then I got the Odin binary in my path. So it has a bunch of commands that you can see over here, right? And what I did was I basically copied this hello world program, and just to make sure everything is right, we do Odin run dot and it's a hello. So this is a simple hello world program that we have in Odin. So you save a file called main.odin using your favorite text editor. I'm using NeoVim over here, and then you do an Odin run to run that particular program. Okay, so you can run the individual files as well, I see. Let's start with the variable declaration part. Variable declaration declares a new variable for the current scope. So we have some types, like we can define an int, we can define multiple ints in a single line. So let's try to do that. Something like this. And what do we get? Oh, I'm familiar with Go. That's why I typed the println P capital, right? And let's see what is the zero value over here. So the zero value for integer we have as int. It's not something like a null or something like that, right? So that's pretty good. And we can do multiple variable declarations in a single line. Let me just try to print, and I'll print z, and let's try to run this. We get 0 0 and 0. Okay, so variable are initialized to like 0 by default. I'll zoom it in, right? And note that the declaration have to be unique within a scope that we know. So you can't do this, you can't do x equal to 10 and then x equal to 20 with this colon equals to. So we have this syntax of colon equals to as well. So plan x, and when we run, we get 10. You can't do something like 20 over here. So you get an error. I'll want to see the error that the compiler gives us. So the compiler says that redeclaration of x in this particular scope, and we get a pretty decent message over here. So we can't do this thing. We can do this. Declaration is not allowed, and yeah, similarly over here. Assignment statements. The assignment statement assigns a new value to a variable slash location. So we do x and 123 x equal to this. So you can give the types over here, something like this. And this is the language server issue, I think. Okay, I'll open the file again. And we do this, we get 10. You can do a redeclaration x equal to 20. That will give us 20. Okay. So this is assignment, right? This is declaration. Okay. Equal to is the assignment operator. You can assign multiple variables with it. So you can do something like this as well. So you can do x and then y. So I don't think you need types over here. You can do 10 and 20. And you can, okay, you need this, right? And x, what if I give it the x and y? How will it print this one? Okay, it says 10 and 20. The language server that I am using right now is the, I think if I do Mason, I'm using this language server called OLS, but I think there should be a better language server. So language server Odin. Let's see, we have the OLS language server. I don't know, it is giving me some sort of like errors, even though there are not any errors. This one doesn't have any. We have OLS. I think OLS is the most used one, or like it is the only server that we have. We have something else over here. Oh, sorry, not here. I need to put this application. So I'll do language server, nothing. So I think I'll use this particular server and ignore these errors that we are getting over here and rely on the compiler. It's compiling fine, right? And colon equal to is two tokens, colon and equal to. This is how it is done. So you say x colon type and then equal to 123, x colon equal to 123, x colon equal to 123. So it does like type inference. It automatically detects the type over here, that from 1 to 3 it knows that it is an integer type. Right, that is cool. Then we have literals. So string and character literals. String literals are enclosed in double quotes and character literals in single quotes. Special characters are escaped with the backslash. Okay. Just one thing I want to check, we are live or not. I'll open my YouTube and see. So we are live, and if I go over here, so we are live. Okay, we are live. And what I can see over here is, yeah, users in chat. Okay. Okay, so I got a bit distracted. Strings and character literals. Literals are enclosed in double quotes, and character literals in single quotes. Special characters are escaped with a backslash. So this is common stuff. I'm not going to go through this. Row literal is this. So row string literal are enclosed in this thing. Okay. You can do backtick as well. Yeah, that's cool. The length of a string can be found using the len proc. This is kind of similar to Python. And what do we have over here? So we do something like string and oh, okay, that's weird. This is my string, and then we do print line string, and then we do Odin. So this is my string is coming over here, and then I can print the length of the string. So this is my length of the string. Okay, length is a compile time constant. The value of length will be a compile time constant. Okay, that's cool. Then we have the escape characters. I'll go over it. We have the numbers. So numeric literals are written similar to most other programming languages. A useful feature in Odin is that underscore are allowed for better readability. Okay, we can do this. And a number that contains a dot is a floating point integer. So we can use this syntax E9. If a number literal is suffixed with I, it is an imaginary number. Okay, we don't need it. Binary literals are prefixed with 0b, octal with 0a 0o, and hexadecimal with 0x. A leading 0 does not produce an octal constant unlike C. Okay, so we have this integer, and I believe what will happen if I do this. And I'll do, what do we get over here? Oh, we get 1. Okay, so this I think gets typecasted automatically. Constant literals are untyped, which means that they can implicitly be converted into a type. Okay, right. And then we have comments, single line, multi-line. That's the common stuff. We have constant declarations. Constants are entities which have an assigned value. The constant's value cannot be changed. The constant's value must be able to be evaluated at compile time. Okay, so we have this x is what, so we can define some constants over here. So constant, and we do print line x. We have our constant over here. Okay, constants can be explicitly, okay, so you can define the type in between this thing. And how do they format it? They format it like this. You can define the type of a constant if you don't want it to be inferred, right? Constant computations are possible, so you can do something like this, which is fine. Now comes the packages. Odin programming or programs consist of packages. A package is a directory of Odin code files, all of which have the same package declaration at the top. Okay, execution starts in the package's main procedure. Import statement. The following program imports the FMT and OS package from the code library. Okay, so there is one thing I want to test. If I have just this thing. Oh, okay. So this programming language Odin doesn't have that weird stuff that like Go has, and I think Zig also has it. That if you define something and then you don't use it anywhere, they usually throw an error. But in Odin, it seems to be working fine. Right. Let's go over this thing. We have a package main. We can import stuff. Right, and yeah. The core prefix is used to state whether the import is meant to look. Okay. This is called a library collection. If no prefix is present, the import will look relative to the current file. Okay, that's fine. By convention, the package name is the same as the last element in the import path. So core.fmt, and packages comprises of files and begin with the statement package fmt. However, this is not enforced by the compiler. Okay, which means the default name for import name will be determined by the last element of the package possible. Okay, so you can give something like this. So you can import this, and you can give, I think, something like an alias. So I'll do foo.println and x, and this should work, right? So this is fine, I guess. And exported names. So all declarations in a package are public by default. So this is public. You can make something as private. Okay, this I'll go through, I think, later on. This is more relevant to if you are developing like a library sort of a thing. Then you have to keep in mind what you want to make private, because by default everything is public over here, right? And authoring a package declaration, example package main. A directory cannot contain more than one package. Okay, so that's important thing. Organizing packages. So packages may be thematically organized by placing them in subdirectories of another package. For example, core image png, core image tga as subdirectories of core image. Okay, yeah, I think we will move on to the interesting stuff now. So control flow statements, we have for loop. Odin has only one loop statement, so there is no while or do while kind of a thing. It just has a for loop, and I believe it does everything using a for loop. Like if you want to write a while loop, you basically write a for loop. So the syntax is such that you can write a while loop using a for loop. Basic for loop. Basic for loop has these things. So this is a C style for loop that we call. What I can do is I can simply do for I is something like this, I is 0, then I is less than 10, I plus plus, something like this. Do we have plus plus? We will find it out. Okay, we have this thing. Yeah, so we have this thing. I'll remove and println I. So we'll figure out, okay, we don't have plus plus, plus equal to 1. Do we have this thing? Yeah. So now we print from 0 to this thing. I pulled out the chat thingy. Yeah. Okay. So this is what we have till now for the for loop. And let's see. So this is the simple C style for loop. We have something like this. We have, oh, we have do over here. Okay, so we can have these brackets or do. I think these brackets would have been simpler why they introduced do, but there might be some reason of having do. Okay, so if you have a single statement, you can write a do instead of providing these brackets. And the initial and post statements are optional. Okay, so you can write something like this. These semicolons can be dropped. You can have something like, so this is kind of like a while loop, right? In another programming languages, what you will do, you will have a while condition over here, right? So this is something like a while loop, and this I believe is an infinite loop. Yeah, so this is an infinite loop we have. So I think we should do some hands-on, and yeah, I'll run it again. So it is something like this. Streaming. And then we have this streaming. Yeah. So this is infinite loop we have. Okay, so let's move on to the next thing. And we are done with this thing. Oh, they have this dot dot format and less than 10. Okay, this is interesting. So let's try to write this one, and we can do something like for I in 0 to less than 10, what we will get. Also want to print the I. Okay, so we get 0, 1, 2, 3, 4, and up till 9. And if you want to do it till 10, we can do something like this. Oh, that's interesting. You don't have to write this for I equal to 0, then I less than 10, I plus plus this stuff, right? You don't have to write this thing. You can use this shorter syntax that is there for I in this thing. That's pretty cool. And where a dot dot equal to b, so this is a and b are both inclusive. Here a is inclusive but b is exclusive. Okay, certain built-in types can be iterated over. Okay, so we have a string and then we can do an, this is like a for each kind of a loop. Let's try to do this. So we have a string that says, okay, let's do something like this. And what we'll do is for character in string, and we do from to dot println c. Let's see, and we get all the characters. Right, that's pretty cool. We have arrays. We haven't covered arrays till now, as far as I can see. Right, I don't see arrays over here, but yeah, we have arrays over here. And I think once we come to the, oh, there's dynamic. Oh, so for defining a dynamic array, you write the dynamic keyword, and then you have a map as well. Okay, I think these types are not yet introduced right now to us, so I'll probably do it in the other section where they are like actually referred to. And right, so we can do something like this. We can do character and index, value and index. Okay, this is pretty cool. You can do I, and then you can do I over here, and you get the index. That's nice. The iterated values are copies and cannot be written to. Okay, that's an important thing. So it is a copy, not a reference. When iterating a string, the character will be rune, okay, and not bytes. Foreign assumes the string is encoded as UTF-8, so every character of UTF-8 is known as a rune, and that's how I think it works. Type of is rune. You can iterate array and slices by reference. Okay, so you can do reference, dereferencing kind of a thing, I guess. Okay, and you can change the value while you're iterating it. That's interesting. Does not impact the second index value. Okay, okay. Map values can be iterated by reference, but their keys cannot, since map keys are immutable. Okay. Yeah. It is not possible to iterate a string by reference because strings are immutable in this language. And for in reverse direction, we can also do, okay, this is cool. What is this hash thing called? Oh, it is so directive. Okay. It's a reverse directives to make your for loop iterate in reverse direction. Okay, that's cool. And what we can do over here, let's take this array and we say this question mark. I don't know what this question mark means. 10 20 30 40. So we have this thing over here. We do for a in arr and dot println a, and this thing. Let's try to run it. Then we get 10 20 30 40, and we can do reverse. This is pretty cool. I haven't seen anything like this in any another language, so this reverse is kind of cool. Yeah. Then we have for loop unrolling. Okay, the unroll directive takes a for loop and expands it at compile time to the individual statements, repeated for as many times as the loop would normally iterate. This may result in performance improvements or provide the ability to repeat a set of instruction a limited number of times without explicitly writing each out in repetition. Okay. Unroll may be used only with ranged for loops and have constant intervals known at compile time. Okay, so what is happening over here? So this is a U8. Okay. Unroll. Okay, I don't understand this unroll thing. So unroll. Okay, we are 30 minutes into the stream. The unroll directive takes a for loop and expands it at compile time to the individual statements. Okay, so this runs like at the compile time. Hmm. So it is kind of an optimization. So from what I understand, if I try to explain this thing, if we have something like this, u8, and which is equal to 0 xff, right? And then you write unroll for b I in 0 to length of x. And if I do from the println I do something like this. Okay. Okay, this is nice. Did you mean this thing? Okay, it so shows you the suggestions as well, right? And you get 0, 1, 2, 3, 0 xff. So this is the index, and then you can refer to x of this thing, I guess. What do you get here? Okay, so you get the values. So f is 255, 258. Okay. Okay, so if you write it as bytes, then it becomes 255, 255. Okay, that's understandable. And okay, I have a power cut situation. Okay, we'll continue. And what happens over here is unroll. Probably what it does is, if you were performing any kind of like operation over here, let's say you are doing XOR, what you will get over here is, so we'll take one more like in the example, and this is 8, and then we get y of I. Let's see this thing. Okay, it prints nothing as expected. And I'll print x over here. Let's see how it prints. So 199, 199. Initially it should be 255s. Okay, right? So we are doing an XOR operation over here. The unroll statement, from what I think, is it will replace this for loop by the, like, this particular statement, like length of x number times. So 4 times we have it, right? And yeah, so it will replace it to something like 0, 1, 2, and 3. 0, 1, 2, and 3. Okay, just give me a minute. Okay, we're good, I think. Yeah, so this is what I think the unroll thing means. And yeah, we can move on to the next thing. So next we have the if statement. Odin's if statement do not need to be surrounded by parentheses, but braces or do are required. Okay, so this body requires this parentheses. Like for the if statement can start with, okay, this is if, and then you do a condition, and then you do a body, right? This is something similar to Go, I guess. See, Go has this thing. It does this kind of stuff with errors, I think. I'm interested to know how error handling works in Odin. So we have a function that might be returning something, and then you can put a semicolon and then compare it. Yeah, that's pretty handy. And if I want to write this particular thing, I'll do something like x If x is 10 and x is less than 10, then print out something, right? And we get nothing because x is not less than 10. Less than equal to, we get something, right? Okay, so this is how it works. Oh, this is nice. So you declare it over here, assign it over here, and declare it over here, and then you can use it in the else if block as well. Okay, so this is probably available in this particular block, I believe. Yeah, I'm just thinking how they would have done it, but yeah, it's pretty cool, I would say. Switch statement or switch statement is another way to write a sequence of if else statements in Odin, the default case. Okay, so we have a switch over here. So we can say arch is Odin arch, and then you do this thing. Okay, this Odin arch thing is what? What do we have? Oh, it give you the architecture that you are on. So you can do something like this. That's pretty cool. I don't have the formatter over here. I think I need to configure the formatter for this thing. And yeah. Okay. We get this thing. Okay, so I 386. Okay, so you can do this dot thing. This is also interesting. Dot wasm dot arm32. Then tells you if you are on like 64-bit or 32-bit machine. So I'm on a 64-bit, so I'm on this side, ARM 64. That's kind of cool. You don't even need like break statements over here. So I think it does break by default, I guess so. Yeah. Odin switch is like, just give me a minute. Okay, I just want to see some stats. So what I'll do is I will have like my other window. Okay, so we have the chats, we have this Twitch thingy. Okay. So what is happening over here is okay. Okay, so the stream is going fine, I guess, and we want to see the YouTube one. Me go to the YouTube studio over the other. So I'm doing things on the other monitor, right? And what I should do over here is okay, I go to the content tab, live. Yeah. So I go to this live stream manager thing. See the analytics. We had some viewers, but there weren't any chatters, I guess. Okay, where do we see the live users and stuff? I'm pretty new to this thing. Okay, I can see it over here. can see it. Okay. And the quality seems to be fine to me. Okay, I just noticed this thing. Yeah. Okay. Okay, we're good. What I will do is I will move the chat up. Mm, Yeah. So if someone is watching, can chat. But let's continue with our adventure over here. Odin switch statement is like the COC++, except that Odin only runs the selected case. This means that there is no need for a break. Okay, to achieve a C like fall through into the next case block, the keyword fall through can be used. Okay. So what it means by that? It hasn't given any example either. Can I do this thing called fall through? And where is my thing? So this is we have over here. What if I do move this up, fall through? What happens over here? Yeah, it prints 64-bit and 32-bit. So you don't have to put a break, but if you want to do the C style kind of switch case, you can do that. Okay, that's interesting. You can execute functions over here. Wow. Okay. Then we have switch x is less than 10, less than 0. From.println x is negative. From.println x is 0. Yeah, this is pretty common stuff. So you can run like a switch statement without any kind of like value over here. So this is not required. You can use it like an if statement. This is something like an if statement over here. But yeah, this is default case, I believe. Yeah, this is the default case. Okay. Switch C is case A, Z, A. Okay. C is alphanumeric. You can write multiple conditions over here. These are like comma separated that we have. I want to give it a try. Let's give it a try. I am not writing enough code. Let's do this switch thingy. Here, right? Something like this. And we have C, which is, let's say A. C is alphanumeric, and if you put a dollar, you don't get anything. And if I write a case, yeah, so this is the default case, and this is how it works. Okay, and yeah, let's move on to the next thing. So this is also switch. You can do pretty like a lot of things with the switch cases. You can define a range like you do in the for loops. That's interesting. And then we have something called a partial switch with enum values. Okay, so this is introducing us to enum. So we define, let's write this thing. And so what I want to do, one thing which is like bothering me a lot, I will just do, I did an update, I guess. I have to delete this thing. How do I delete this thing? Okay, G question mark. Remove. Nothing. delete nothing. Um. Okay, then we don't have the option to delete it. We have to deal with it, I guess. So we have this enum with us, and we're going to define it. So I'm copy pasting. I shouldn't do that. I will be writing it by hand, and the reason is I want to get familiar with this language. So you can have. Can you have the enum inside a function? I don't know. We'll know in a while. And you do something like this. Then you do A, B, C, D. Okay, you put a trailing comma over here, right? And we have foo. Then we say F is foo dot A. Let's do a simple thing like this. Okay, we get A. So you can define an enum inside a function, and you can do switch on this thing. So I can do switch on F. Then we say dot A, and we say case dot A is from the print line. Okay, was partial switch. Okay, so I believe by default you kind of want to cover like all exhaustive possible values over here. So you would have to write B, C, D, everything. Let's do it quickly. And B, C, D. Now it will run. It says A, but if I remove like any case, it will say C and D is not there. And do you want it to be a partial switch? So you can say partial, then it works fine. That's cool. That's cool. So there are union types, int or bool. Okay, this is interesting. Foo is 123, and then we get int switch underscore enough. What in the abomination is this thing? I don't understand this thing. Switch underscore enough. Okay. Does it give you the type or something? I'm interested in this example. I'm interested in this one. So let's do one thing then. Let's say take this example. We say this is a union of integer and bool, right? And we say f colon foo is equal to 123. What if I do something like switch f case int from dot print line f int, and similarly I do it for bool. Okay, bool is not an expression but a type. In this context is ambiguous. Okay, so it says it's a type, right? And what we can do over here is we can do this syntax. So we can do underscore in, right? And then it says integer. Okay, so somehow it gets the type of that thing, I guess, or the underlying structure that we have. This is a bit confusing in my opinion, a bit confusing. Yeah, but anyways, similarly we have partial over here. We have defer. Okay, so from coming from Go, I understand the defer statements. So defer statements are pretty cool, and the reason is you can do something like this. You can say uh hello, and you can say defer. Okay, I don't know. You can say world, and uh, hi, right? We do something like this. So what will be the output? You get hello, you get hi, and then you get world. So basically, whatever is deferred means once the execution of this block is completed, then run those statements, right? So we get hello, hi, and then we get the world. So this is pretty interesting because in things like closing a file, so let's say you open a file over here and then you have to close a file and you do bunch of things here, right? So if you do a bunch of things here, you can have errors. Either you wrap it in a try and catch, something like you will do in Java. Probably you can use try with resources and stuff, but instead of doing this close here, you can do this close here, and you can just defer it, right? So this is the benefit of defer. And we are stuck with stupid errors. Ah, I need to get rid of these errors. Mason we don't have. Ooh, we have uninstall. We uninstall this thing, please. Okay. Okay. Now it's better. Now it's way better. Okay, let's continue with the defer. So what example have they given us? They say x is equal to 1 to 3 and then defer. So it will be like a fun exercise to guess the output of this particular thing. So we have x. So basically in the output, what you should be getting is do multi-line comment. So I'll say output will be according to me. So you do a defer x is 2, x is 4. So let's think through this example, right? This will run at the end. So basically it will run here, right? And we have 2, we have 4. So I think 4 should be printing first because this is deferred. So after this block, x will become 4 and 4 will come, then x will become 234, and then we should get 234 over here. This is my guess. Let's try to run this program and see. So we get 4 and 234, right? So let's move on to the next part. You can define an entire block too. Oh, okay, this is interesting. You can defer a block. You can have multiple statements in defer. Oh, we have defer if condition. So this defer is probably like more advanced than the defer we have in Golang. So yeah, defer if condition. Conditional defer is there. That's interesting. Hmm. I think it's interesting, but I don't see an obvious use case on top of my mind for this particular thing. But I believe we'll find one once we do some like projects and one thing in Odin. Defer statements are executed in the reverse order if they are declared. We know that. A real world use case for defer. So this is what I was talking about. You can do os.open file and then handle the error and then close. You can do the defer close. That's interesting. Yeah. In this case, it can act akin to an explicit C++ destructor. However, the error handling is basic control flow. Also, I see the error as value thing, which is similarly in Golang that we have. Right. The defer construct is in Odin refers from goes defer, which is function exit and relies on a closure stack system. Okay. Then we have the when statement. Okay. When is something new for me. I'm not sure Go has when because I've never used it. Okay. I don't think Go has van. Okay, this AI generated slop is over here. It got us. I said no AI. Still got us. And yeah, we have sync package. We don't have a when. Okay, what it says is when statement. The when statement is almost identical to the if statement, but with some differences. Each condition must be a constant expression, as a when statement is evaluated at compile time. Okay, the statements within a branch do not create a new scope. The compiler checks the semantics and code only for statements that belong to the first condition, that is true. Okay, only the first condition, that is true. An initial statement is not allowed in a when statement. Okay, when statements are allowed at file scope. Yeah. Okay, what do we have here? So Odin Arch again, that we have 32-bit. Else when this, the when statement is very useful for writing platform specific code. This is akin to the percentage if construct in C's preprocessor. However, in Odin it is type checked. Okay, I'm not much aware of the if construct in C, so I'll move on to the next section. Branch statement. So we have which case break. So we have the break thing. Okay, you can do a named break as well. Just give me a minute. Okay, I got this break thing, and we have for condition, then we have switch case if condition. So this is fine. You can have labeled for conditions and then you can break certain label. This is fine. I think we should move on. We have continue, which is classic. We have fall through. We have seen this. Now we comes to the procedures. Okay, let's, before going into procedures, I'll probably need like 5 minutes or something. So what I'll do is I'll put it on. Okay, we can probably continue with procedures and then see, because I need like a small break, right? Yeah. And for procedures, what do we have in Odin? A procedure is something that can do work, which some languages call functions or methods. A procedure literal in Odin is defined with the proc keyword. Okay, so it is a function kind of a thing. So we have the Fibonacci function over here. Let's try to write it down. I would say, for some reason my change in this thing is not working. Okay, now it's working fine. So we write the function name Fibonacci, and then we give the proc. We take an input of type integer and then we return an integer. Okay, and then we have the switch case is 0, or you can write n is less than 1. Then we return n, like return 0, I guess. We can return n. So we can do something like this. So less than equal to 1, we return n, and otherwise we simply return Fibonacci. Okay, Fibonacci of n minus 1 plus Fibonacci of n minus 2. And we are not running this function. Fibonacci of 5 or 3. Okay, and we do println. We get 2. We get two. I think it's fine. I don't remember Fibonacci. Yeah, it's two. Yeah, I remember. It's 2 plus n minus 1 will be 1, and then Fibonacci of 1 will be 1. Yeah, we are good to go. See this. This will be 1, as I said. And yeah, this is it. Parameters. Procedures can take 0 or many parameters. The following example is a basic procedure that multiplies two integers together. Okay, this is pretty simple. Then we have this thing, accent int. You can write int once. And by default, Odin procedure use the Odin calling convention. This calling convention is the same as C. However, it differs in a couple of ways. It promotes values to a pointer if that's more efficient on the target system, and it includes a pointer to the current context as an implicit additional argument. The promotion is enabled by the fact that all parameters are immutable in Odin and its rule are consistent for a given type and platform and can be relied on since they are part of the calling convention. Okay, passing a pointer value makes a copy of the pointer, not in the data. Okay, I get this thing. Yeah. Shadowing parameters. The the mutate to mutate the procedure parameters, an explicit copy is required. This can be done through just. I'll take a short break over here. We are back now, and what I'm going to do is continue with this thing. So we have shadowing parameters. We were here to mutate the procedure like in C, an explicit copy is required. This can be done through shadowing the variable declaration. So okay, you can shadow these. That's fine. Variadic parameters. Procedures can be variadic. and taking variable number of arguments. So yeah, that's cool. And let's try to write it down. Okay, so I'll keep the Fibonacci one. So sum is going to be a proc. How do we give this thing? So nums and dot dot integer. Then we say result, which is an integer. Okay, we have named return types over here, I think. Right, so we have named return types. And let's see, we have, okay, so we have sum, which is nums of integer, and result. Oh, we can just do a return. This is interesting. This is interesting. Let's try to write this down for num and nums result plus equal to num, and then we do a return, and I can do sum of 3. We get 3. I can do 3 plus 2. We get 5. Ooh. So this is kind of nice. You can just do a return and then you can use this result inside here. That's pretty cool. That's pretty cool. Okay, and we get this thing. Okay. Oh, we can do like unwrapping sort of a thing. So we do dot dot dots, and that it passes it as like each value is a parameter. Multiple results, we can return multiple results from a function. We can write a swap thingy. We can write this swap without any temporary like variables. How cool is that? Can your programming language do that? So let's write this function swap, which is a proc. Okay, xy, which will be integer, and it will return an integer. So we'll return y comma x, and we say swap two numbers, 1 comma 2, x comma y, right? Yes, we get 2 comma 1 here. That's cool. That's pretty cool. Right. We come back to this multiple result is done. We have named result. So we have seen named result already. If this input can do this thing. Assign default values to named result is also possible. Okay. Okay. Yeah, this is quite cool. Sorry. And this thing. So we can write like O is can what, something like this, and you take age as integer, and you say, hey, I want to say by default don't allow it. No. Nope. We say nope. And if age is greater than equal to 18, we say return, we say result equal to yep. What if I don't do a return over here? What if I don't do that? What will happen? Let's try to see what will happen in that case. So we get this thing, we do from dot println can vote 17, right? Let's see. Oh, missing return. Would have been cool if I didn't have to write that return. So we get nope because you can't vote, and here you get yep, you can vote, right? And next what we have is named arguments. Okay, we can have named arguments. When calling a procedure, it is not clear in which order the parameter might appear. Therefore, the arguments can be named. Okay, we can do title equal to this, monitor equal to this. What is this thing? I don't understand this. Is this pointer? We'll see. We'll see. Mixing named and positional argument is allowed. Okay, you can do positional and named because most of the languages don't allow this thing. If you do a named, you have to do everything named, right? Default values. The create window procedure may be easier to use default values. So you can give the default values. Oh, I hate this scroll thingy in macOS. Sucks. Default values we can give. That's good. Explicit procedure overloading. We have bold to string, into string, to string. Okay, what is this thing? We have 1 hour and 12 minutes into the stream. Rationale behind explicit overloading. The design goals of Odin were explicitness and simplicity. Implicit procedure overloading complicates the scoping system. In C++, you cannot nest procedures within procedures, so all procedure lookups are done at the global scope. An Odin procedure can be nested within procedures, and as a result, determining which procedure should be used in the case of implicit overloading is complex. So you do explicit overloading. You say foobar, foobas. I don't get it. I don't get it. Okay, so we are jumping onto the types. But I want to like understand this particular thing that we have over here. So we have bold to string. Rationale behind explicit overloading. The design goals of Odin. We have read about this thing. This is something that I'm not sure right now how it works. Can we like write a simple example for this? Now if I run to string and I pass 10, what do we get? Mm, we get integer, and if we pass false, we get bool. Okay, so you can do type over, not type overloading. What was it called? You can do procedure overloading, but you have to define it under a scope. You cannot have like same names as you do in like other programming languages where you have same function name and this would differ, the parameters would differ, or the return type would differ, right? In here you can give different names and then you can bunch it into another proc. Okay, that's cool. That's something new about this language. I have seen a lot of new things in this language. So yeah, basic types are boolean. So we have b8, b16, b32, b64, and i8 unsigned integers, endian specific integers. So I okay, big Indian, okay, little Indian and big Indian. Okay, okay, okay. With floats, we have Indian specific floats. We have quaternion numbers. What the hell is a quaternion number? I don't get it. Let's go Wikipedia. Okay, complex numbers. Iota and thing. Signed 32-bit integer is a rune. Unicode code point is a distinct type to I32. Okay, strings, and we have C strings. What is a C string? I want to know. We have row pointer type. We have runtime type, specific information, type ID, and any. The uni pointer type is point sized, and the int uint types are natural. Okay, we have zero values. I don't want to go over this. We have typecasting. Okay, typecasting. We can cast things from one type to another. Um, so if you have like x, which is of type integer, right? You can cast it to a float, and the syntax is you say cast to f64x. We're not printing anything because we are stupid. We get 69 as integer, as float. So this is typecasting that we have, and this is useful in some context but has the same semantic meaning. Transmute. What is a transmute? I don't know. Transmute operator is a bit cast conversion between two types of the same size. What is this? What the hell is this thing? I don't get it. I don't understand this thing. So they haven't introduced like pointers yet, but they're using it. So maybe like introduce the pointers above and then use it. So I'm going to leave this transmute thing, and we might come later on. Come on to it. Untyped types in the Odin type system, certain expressions will have an untyped type. An untyped type can implicitly be converted to a typed type. Okay, that was a mouthful, and we have strings, booleans. Nothing interesting over here. Oh, you can do autocasts. You can do autocasts. This option is only recommended to be used for prototyping and quick tests. Please do not abuse it. Please do not abuse it. Right? Don't use this. I mean, I don't know much about this thing, but yeah. Built-in constants, values, and procedures. False. It says true, nil. Oh, we have nil. We have nil and go line. Is useful if you want to explicitly not initialize a variable with any default value. Initialized with its zero value uses uninitialized memory. Y is an integer. This is the default behavior in C. Okay. And Odin is zero. The memory is not a contract in that it is an initialized. Okay. Let's jump. Okay, we have code point and then the index. We have done this thing. I'll not go through this thing again. String formatting. We have this thing. For some reason, when I press backtick, I get this thing. Like, what the hell is wrong with my keyboard? Or is it like terminal thing? Let me open item. See, I get this thing and this thing. How do I press backtick on my keyboard? What the? Let me see the keyboard settings. Edit. Okay. Finally, I can type. Hang on. Okay. We can do fummed and then something. We have structures over here. Okay. I'll ignore the structure for now. They will probably come in some other section. And what we do is fummed and this thing is to 0 q2n. Okay, let's see it later on, I guess. So C string, the C string type is a C style string which is 0 terminated. It is equivalent to char const star in C. Its primary purpose is for easy interfacing with C with the foreign system. So it has a FFI thing, foreign inter system. Okay, we'll not be covering this thing, by the way. So we have the C string and then string. For most part, I think we will use string. But if you are like writing a foreign interface to some C library, you will probably use C string. Okay. String type conversions, you can do all this jazz, which I don't want to go through. We are on to the operators. Operators are common. Oh, this float. Okay, this slash like in Python. I don't think so. But let's do. Hmm, okay, by default it truncates, so you have to do a cast, I guess. Okay, okay. These are common things that is in each programming language. Address operator. Okay. I think we are coming to that dangerous territory now. We are onto the address operator. We'll have pointer and stuff. Dynamic arrays. Pointers. The pointers. Structs. So this is like a huge documentation. I was thinking of covering in like a single stream, but I don't believe I can do that. We have came till address operator. I think I will go till the advanced type and then close the stream and come back again and try to look at more things. Yeah, I guess I'll do that. I'll check some things. Check some things. Okay. Okay, what can we do here? Yeah, so address operator. For an operand x of type t, the address operator is ampersand x. So this is similar in C. Generates a pointer of this t to x. The operand must be addressable, meaning that either a variable pointer in direction or slice array indexing operator or a field or addressable. Okay, I get it. Okay. Yeah, then we have the ternary operators. So this is like C style thing. You can have when, you can have if as well. We have done these loops. Operator precedence is also same, I believe. Integer overflow, advanced types. Okay, we are in the advanced type section, and what I believe is this is a good time to close the stream, and we'll continue from the advanced type section. What we have left is a lot of important things: type alias, distinct types, fixed arrays, slices, dynamic arrays, enumerations. Enum we have seen. Yeah, bit sets, pointers, structs, union, map, bit field. I think or else expression or written conditional compilation, file suffixes, implicit context system. Oh, this I think is an interesting part. This thing, allocators. I've heard about the allocators a bit, but I'm not sure of this. It is said that they have pretty good default allocators, memory allocators in Odin. And yeah, explicit context logging system, foreign system using a vendor library. So this is more of like, this overview is quite a big section, I would say. This will take a lot of time. Bad. Okay. Expression statements, built-in directives, panic. Oh, we can panic. All right. So I see a lot of things in this section. Basic idiom, ternary operator, if statements with initializations, defer if, advanced idioms, implicit type conversions. So what I'll do is I'll try to like cover the advanced type section in the next stream, because we have covered a lot of things in this one. We will cover the advanced types, and let's see how much we can do in the next stream. And yeah, so if you are watching this video later on, you will find everything in the description below. And yeah, thanks for watching, and that's all for this video, for this stream.